Let's start يا شباب today class chapter 1, which is the engine types, parts, and also the classification of the engine. As I told you, يا شباب, you can just follow from the book by bulk graphic, but inshallah you will find all of the information, all what you need, inshallah you will find in slides. And I used to solve actually many examples in my slide. You will find also many examples are available here, in addition to the homework. So I think inshallah that should be enough for your exams. Inshallah, the outline for this chapter will be just talking about introduction. Then I will be talking about the heat engine. Any heat engine is a device that converts the heat into work or shaft power. I will be talking about the classification of the internal combustion engine, how we can classify the internal combustion engine, and also the parts of the different part or the component of the internal combustion engine. I will be talking also about the different configuration. We have inline, V-type, we have H-type, horizontal, radial. All of this configuration of internal combustion engine will be considered. And also I will be considering a special case of internal combustion engine, which is the Wankel rotary engine. We'll be talking about this as well. And then I will be talking about the main difference between the spark ignition and the compression ignition engine. Spark ignition, which is the gasoline engine, and the compression ignition, which is the diesel engine. Also, as I told you, all of this engine, each engine is working on a cycle. So if the cycle is completed in 4-stroke of the piston movement, we call it actually the engine is working on a 4-stroke cycle. Or actually, if the cycle is completed for only 2-stroke movement of the piston, we call it actually the engine is working on a 2-stroke cycle. Inshallah, I'll be talking also about in this chapter about the operating cycle and also how we can represent the cycle on the PV diagram, and also I'll be talking about the valve mechanism and how we can actually extend the valve opening in case actually of higher RPM of the engine. طيب, this is just an introduction or just a kind, I just want to brainstorm you what do you know about the internal combustion engine. So usually the internal combustion engine are either a spark ignition engine, or we call it actually the gasoline engine, or we have a diesel engine, which we call it compression ignition engine. So do you have an idea about the difference between those engines, gasoline engine and diesel engine?
I believe, Doctor, the gasoline engine ignite or combust by a spark. It is a spark to ignite. Where the diesel engine combust due to the high pressure.
Exactly. So this is the main difference, Shabab. So we call it gasoline engine, we call it a spark ignition, because we have a spark plug here in the cylinder that actually create a spark to start the combustion process. As you see here, when the spark is started, then the combustion process is initiated, then high heat release is created here due to burning the fuel, and it will push the piston down to go actually down to the cylinder. And this is actually, we call it a spark ignition engine or gasoline engine. In case of the diesel engine, Shabab, it is the same engine, but we don't have a spark plug in this case. The fuel itself is characterized actually by self-ignition at high pressure. So when the piston is going down, it will actually just take the intake charge of fuel plus air, and then actually it will compress this air while the piston is moving up. It will increase the pressure and it will increase the temperature. Then in this case, instead of the spark plug, we have the fuel injector. So in this case, in case of diesel engine, there will be, instead of the spark plug, a fuel injector that will inject the fuel directly inside the cylinder under high pressure and high temperature. Then the fuel actually will self-ignite, and also it will be actually releasing the heat and repeating the process to generate power. So the main difference between gasoline engine and diesel engine, gasoline engine we have a spark plug at the top of the cylinder. Diesel engine we have actually a fuel injector instead of a spark plug, and the fuel actually is self-ignited within the cylinder. If you look at any internal combustion engine, like the engine actually if you have a car or something, the internal combustion engine consists of a cylinder and piston cylinder device, and we have here the intake valve. The intake valve is operated using a camshaft. The cam has a tip point. When it is rotating actually and the tip comes actually to press the intake valve will be opening. And if you look here, we have the air filter, and then we inject the fuel before actually the upstream of the intake valve. Then we have a mixture of air plus fuel. When the intake valve opens, this mixture will just introduce to the piston to inside the cylinder, while the piston is moving down. When the piston is moving down, it will create actually a low pressure inside the cylinder to actually suck this air plus fuel inside. Then the piston will be moving up. It will compress actually this mixture of air plus fuel to high pressure, high temperature. Then the spark will generate the spark to start the combustion process. Once the combustion is started, it will push the piston down to generate the power stroke. And then actually the combustion is completed, and the last stroke actually the piston will be moving up and the exhaust valve will be opening so that we can have the exhaust leaving the engine in this case. So Shabab, when we have, if we have a piston here, let's say actually this is the cylinder, and inside the cylinder we have this piston. We have the intake valve here, Shabab, in which we have the air plus fuel are introduced actually through the intake valve, and here actually we have the exhaust valve where actually the exhaust is leaving the piston. This piston, Shabab, is moving inside the cylinder in a reciprocating motion. It is moving up and down. The top point here that the piston reach within the cylinder, we call it actually the top dead center. The lowest point actually that the piston reach within the cylinder when it is moving down, we call it actually the bottom dead center, the heat point, the bottom dead center, the lowest point that the piston can reach within the cylinder. So while the piston is moving from the bottom dead center to the top dead center, this distance, Shabab, we call it the stroke. We give it actually the stroke, it has a symbol A. We call it one stroke. So first of all, when the air is introduced within the cylinder, while this piston is moving down, it creates actually low pressure inside this cylinder. So it will be able actually to suck the air inside the cylinder. So the piston will be moving down from the top dead center to the bottom dead center. And then actually after sucking the air plus fuel, the piston will go back and it will be moving upward. It will be actually compressing this air plus fuel until it reaches actually to the very close to the top dead center. Then in this case, we have here actually a spark plug. This spark plug will be initiating the combustion process, and then actually it will generate heat. This heat actually will be pushing the piston down inside the cylinder to generate actually the power stroke, and at the end actually the piston will be moving up just actually to exhaust the exhaust gases. So the stroke movement, Shabab, is the movement either from the bottom dead center to the top dead center, or the movement actually from the top dead center to the bottom dead center within this cylinder. This is the main difference or the main idea of the internal combustion engine. As I told you, there is gasoline engine, there is diesel engine. This is actually the main two types of internal combustion engine. And I think you should have heard also about the V8 engine. Have you seen this term, Shabab, in your life before? What does it mean, V8 engine?
Yes.
So what does it mean?
8 piston in the engine.
So
8 cylinders.
So the engine, Shabab, usually any engine, it consists of multiple cylinders. Those multiple cylinders can be arranged like in line to have actually just in line in one line. Or if we have actually a big engine like SUV car, you maybe have actually a V-type engine. So we have two inline engines. They are taking the shape of the V-type. 8 mean actually we have this engine is of 8 cylinder. And I think also you have heard about turbocharged, supercharged engine. As I told you, we use a compressor to increase the charge of air to the engine. Then we can increase the fuel so that actually the power output of this engine can be increased. And also, if the engine, Shabab, is working, we call the engine is a 4-stroke engine. If the engine complete one cycle in 4-stroke movement of the piston. What does it mean, cycle, Shabab? Cycle is a complete process, starting from taking the air plus fuel, sucking it while the piston is moving down, compressing it, then we have burn combustion, then we have the power stroke, and then actually the last stroke, the 4th stroke, will be the exhaust when the piston is moving up, just actually to exhaust the gases. In this case, we call this engine as a 4-stroke engine. Okay, so it completes one cycle since taking the fuel until we have the exhaust gases in 4-stroke of the piston movement. Then we have to repeat this cycle in order to generate continuous work. There is another kind actually, Shabab, of engine which combine the intake stroke plus the compression stroke in one stroke, and it combines also the power stroke with the exhaust stroke in another stroke. So in this case, the total number of stroke for one cycle, since taking the fuel plus air until the exhaust, it completes this cycle in only 2-stroke movement of the piston. Piston moves down, it takes the air. So if piston moves up, while moving up while the compression, it also has the intake stroke. Then we have the spark plug, then we have the expansion, and at the end of the expansion stroke, we have actually the exhaust stroke. So the engine completes the cycle in 2-stroke. Inshallah, we'll be talking about the main difference between 4-stroke and 2-stroke engine by the end of this chapter. The 2-stroke engine, Shabab, is used mainly actually in a small single cylinder, yani in some rare application, or it can be used actually in a small single cylinder engine, like the engine used actually in the motorcycle. Most of the motorcycle are 2-stroke engine. Also, you should have heard about the rated power. If you sell a car or something, you will see actually the seller gave you, he said actually this car is giving a rated power at a given RPM, at a given revolution of the crankshaft. Also, internal combustion engine has different application. It has actually the different application in the marine application, in the ships, and also in the boat. Usually there is a diesel engine that is used actually to drive the boat or ship. And also, we will be talking about the fuel economy. So if you are getting a car or something, he will say actually this car can run for, let's say, 10 or 12 kilometers for 1 liter. So, and this is actually a very important parameter when comparing actually one car to another car. Inshallah, we'll be talking also about the ignition and the injection system. The ignition system, Shabab, is not just the spark plug. A spark plug here actually is the last component of the ignition system, but there is a battery, which is the initial source of the volt and the current. And then we have the ignition coil, which amplifies the volt so that we can generate the spark in it. So inshallah, I think this will be a topic to be assigned for one group of you to present us actually the component of the ignition system. Also, we'll be talking about the injection system. Fuel injection system here, actually fuel is injected upstream of the intake valve, but there is a component for the injection system, including actually the fuel pump and the fuel line, and how we meter the amount of fuel depending on actually the required RPM of the crankshaft. Also, we'll be talking about the hybrid vehicle, as I told you, hydrogen fuel cell, and inshallah we'll be talking about the solar car, and I think you have heard about the KFUBM solar car. I think this car has participated actually in the annual race. There is annual race actually for solar car, which is being held actually in US and Australia. Every year there is a race for solar car. So hopefully, inshallah, we can have a group of you participating in this race. Let's go ahead with this course. So inshallah, I'll be starting with the definition of the heat engine. Heat engine, Shabab, is any engine that converts the heat into work, like the internal combustion engine. We convert the heat into work, and any heat engine should be working on a cycle. Working on a cycle, Shabab, means doing a number of processes like the intake stroke, compression, expansion or power stroke, then exhaust stroke. We call this actually processes. All of these processes are forming one cycle. And for the engine to generate continuous power, this cycle has to be repeated again. Then in this case, we call it actually as a heat engine that can convert the heat into work. The heat engine, Shabab, can be classified either internal combustion engine. Internal combustion engine mean actually the combustion take place within the same unit in which we get the power. So if you look here, we burn inside the internal combustion engine, and then we can generate power. The piston will be moving down. Then the reciprocating motion of the piston through a connecting rod will be converted to a rotary shaft motion. So in this case, we have burned within the engine, and we got the shaft power within the same unit. So that's why we call it in this case as internal combustion engine. We burn the fuel within the same unit in which we can generate shaft power. We don't have any kind of working fluid in this case. But we have another kind of heat engine, which is called the external combustion engine, in which actually the combustion takes place in one unit, and then we can generate the shaft power in another unit. So the heat engine are classified either internal combustion engine or external combustion. Internal combustion engine, it can be reciprocating engine, like here, Shabab, the piston is reciprocating. We call the internal combustion engine as a reciprocating engine. like gasoline engine and diesel engine, or it can be rotary, like the Wankel rotary engine. Or in case of gas turbine is a rotary motion, is a rotary machine. We call it actually in this case as a rotary internal combustion engine. Or it can be external combustion engine, which can be also reciprocating and rotary. Reciprocating internal combustion engine like the steam engine. So if you have seen an old movie, Shabab, you have seen actually there are some trains or something in which actually they burn fuel, they burn coal and wood and something like this to drive actually this train. So this train is operating using a steam engine. It is the same as the internal combustion engine, but instead of burning fuel in this case, there is a steam. They burn coal and wood and all of this to generate steam at high pressure and high temperature. Then this steam is introduced actually to move this piston. So in this case, we call it actually as a steam engine or reciprocating steam engine. There is also another example which is the Stirling engine. You can look also at this engine. And also external combustion can be rotary engine, like a steam turbine, or like the cycle or the closed cycle of a gas turbine. So gas turbine, Shabab, can be classified as internal combustion engine if the cycle is open cycle, and if the cycle is a closed cycle and there is a working fluid for a gas turbine, we call it actually, we classify it as external combustion engine in this case. And also external combustion like a steam turbine. As I told you, external combustion means we burn the fuel in one place, in one unit, and then we generate shaft power in another unit. Like a steam turbine, which is used in the steam power plant to generate electrical power. The cycle in the steam power plant consists of a water pump, which pumps the water to the high pressure of the boiler. Then we burn here the fuel to boil up actually this steam. And the steam under high pressure and high temperature will be passed through a turbine. Then it can generate a shaft power in this case. So in this case, Shabab, we generate the shaft power or the work in one unit, but we burn the fuel in another unit. And in this case, there is a working fluid, which is the steam in this case, to generate the power. So in this case, we classify in this case the steam turbine as external combustion engine, because we burn in one unit and we get the power in another unit. But what about the gas turbine? This is the steam turbine. What about gas turbine? Gas turbine, Shabab, I have to tell you that Saudi Arabia is the world top country in using gas turbine. And it is used in the electrical power generation as well. But usually gas turbine is an easy unit to start and easy unit to shut down. So usually in combined cycle power plant, we have both of them. We have a steam turbine to provide the basic load, and then actually, as you know, the electrical power consumption, it changes from time to time. So I think here actually the top required load is at the noon time, because air conditioning is working at the most due to high temperature, so we need extra power. So in this case, the steam turbine will be providing the basic load, and in this case, we can run additional gas turbines actually to provide the additional required electrical power. Gas turbine is easy to start. At a minute, you can just start a gas turbine, but a steam turbine, Shabab, to start a steam turbine, it takes about 2 to 3 days to start a steam turbine. Okay. So what is the idea of gas turbine, Shabab? We should have an idea. Gas turbine is a device that consists of compressor. It's connected in the shaft to the turbine, and in between of them we have the combustion chamber. So in this case, air is introduced by the compressor to the high pressure, raises its pressure to the high pressure combustion chamber. Then it is burned actually with the fuel. Then we can generate exhaust gases under high pressure, high temperature. Those exhaust gases will be expanding inside the turbine to generate shaft power. And this shaft power, Shabab, if it is used in electrical power plant, it is connected, actually shaft power is connected to an electric generator to generate electrical power. And then the exhaust gases will be leaving the turbine. We just exhaust them to the atmosphere. We call it open cycle in this case. And then we'll take the air and we'll be repeating this cycle. So this is open cycle gas turbine, in which actually the exhaust gases are used to expand inside the turbine and to generate power. So we don't have any working fluid in this case. So we classify it in this case as internal combustion engine gas turbine, as the cycle is open. But in some cases, Shabab, they use actually a working fluid in order to improve the efficiency of the cycle. They can use helium or a kind of argon or something. Those gases have higher specific heat ratio. So they can result actually in higher thermal efficiency of the gas turbine. So in this case, actually, Shabab, instead of using the exhaust gases directly to run the turbine, in this case, we can burn the fuel inside the combustion chamber, and we can have a heat exchanger in which we exchange this heat with the working fluid, which may be helium or argon or something. So it will absorb the heat like the steam here, and then this helium under high pressure and high temperature will be expanding inside the turbine, and then it will not be exhausted to the atmosphere, just it will be taken back by the compressor, and the cycle will be repeated again. So in this case, Shabab, we have burning the fuel in one unit, and then we heat up the working fluid. The working fluid is used actually to generate the power in another unit. So in case of closed cycle gas turbine, we consider the cycle, ya Shabab, as external combustion, because we burn in one unit and we get the power in another unit. Do you have an idea, Shabab, about the turbine? How the turbine works? So, Yazid, Hussein, so do you have any idea about the turbine? How it consists of? So if you look at this part, Shabab, what I'm talking about, which is the turbine here, any turbine, Shabab, consists of fixed blade. So usually fixed blade takes the shape of nozzle. We call it nozzle, or we call it fixed blade. Okay, the flow is coming, which is either exhaust gas in case of gas turbine. So this flow is coming under high pressure and also under high temperature. This fixed blade, Shabab, is just fixed, so the flow will be forced to go inside this nozzle. As you can see, the area is contracted in the flow direction. So usually the flow through the turbine is a steady flow. So we have the mass flow rate is the density multiplied by the area multiplied by the flow velocity. So at a steady flow condition, this mass flow rate is constant with time. It is not variable. And usually we don't have a change in density. So what will happen to the flow, Shabab, when the area is reduced in the flow direction? So when the area is reduced at fixed mass flow rate, so what will happen to the velocity, Shabab? Velocity will be what? Velocity will be increased in this case. So we'll have actually a jet. The flow will be creating a jet of high velocity. Then actually there is a rotating shaft of the gas turbine in which actually we have impeller, and on this impeller we are fixing a blade. So the flow will be leaving with very high velocity. It will just hit this bucket, and there is an impeller here or shaft. So it will be rotating actually this shaft. It will hit the bucket. So actually this shaft, it will be forcing this shaft to be rotating and generating shaft power. And usually, Shabab, the gas turbine is not only one row of fixed blade and one row of moving blade. It consists actually of different row or a number of rows in this case. So if you look at actually an axial gas turbine, it consists actually, it's a kind, this is the impeller. Here actually this is the impeller. The impeller have actually the moving blade. In different row, it consists actually of number of rows actually of moving blade around the circumference. So actually the flow is coming here, and to the fixed blade we having, those are the fixed blade, and those are actually the moving blade attached to the impeller, which are rotating actually this shaft. And then we have another row of fixed blade here. Between each two moving blade, we should have a row of fixed blade here attached to actually to the outer casing of this impeller. Then the flow will be coming. It will be forced to go here between the fixed blade, and then it will generate a high velocity jet here that will hit actually this bucket, this moving blade. Then it will be rotating actually, it will be rotating this shaft. And then the flow will be moving from one fixed blade to another, to moving actually to the next stage of fixed blade plus moving blade. Then we can generate continuous shaft power in this case. So the idea, Shabab, of the gas turbine, of any turbine, gas turbine or a steam turbine, that we have row of fixed blades that can generate high velocity jet that can hit the bucket, so that actually we can generate a shaft power in this case. So do you know the difference, Shabab, between internal and external combustion right now? What is the difference? So Yazid?
Yes,
So what is the difference between internal and external combustion?
And the internal combustion, we have the ignition spark.
Internal combustion, that means we are burning the fuel within the same unit in which we generate the shaft power, like here. Internal combustion engine, we burn the fuel to generate heat, then we can generate shaft power within the same unit. But external combustion means actually we burn the fuel in one unit and then we generate the shaft power in another unit. Gas turbine يا شباب is classified as continuous combustion. So the combustion is continuously running, but in case of internal combustion engine here, you can see we burn the fuel and then we have power stroke, then exhaust, then we have to repeat the cycle, take the air back to the engine, compress it, then we have instantaneous combustion at a given moment. And then actually the combustion will stop until we have the other stroke. So we call it actually instantaneous combustion. This is for the case of internal combustion engine. But in case of gas turbine, the air is compressed by the compressor and it is continuously burning with the fuel inside the combustion chamber. So the combustion here is a continuous combustion in case of gas turbine. Okay. طيب the main advantage يا شباب of internal combustion engine, which are used actually in the car, it generates mechanical simplicity. The system is simple. It can provide high power output actually per unit weight, and it has low initial cost because we have wide variety of application of the internal combustion engine, so that we can have massive production that will reduce the cost. So it has actually low initial cost for internal combustion engine in comparison to gas turbine and also to steam turbine. It should have actually low cost. And it have high peak thermal efficiency, and also the fuel economy for the internal combustion engine is fine. The unit are also compact and it can require less space. You can look at your car, the engine actually is just taking very small space from the car. So it is compact unit for internal combustion engine, and it is easy to start and easy actually to shut down. You can start your car very smoothly and also you can shut it down actually very smoothly. It does not require elongated time like the case actually of a steam turbine. A steam turbine in a steam power plant, it can take up to 2 to 3 days actually to start a steam turbine. But the main disadvantage of the internal combustion engine, it have reciprocating part, and the combustion, the piston is reciprocating, and this is actually a source of vibration within the engine. So usually it should have a kind of vibration, and we should be able actually to dampen those vibrations. Also, another thing for internal combustion engines, they cannot actually work with solid fuel, like coal or wood or something. We cannot apply wood in your car to drive your car with coal. So it can only use actually with liquid fuel, and in some cases it can run actually with gaseous fuel. And those fuel actually, gaseous and liquid fuel, are a little bit expensive actually compared to coal fuel. Okay. The application of the internal combustion engine, you can find them actually in different application, in automotive, in railway station. This is a kind of diesel engine, most probably is used in this case. Also in some small aircraft, ya shabab. Usually the aircraft is running using gas turbine. But in case actually of a small aircraft, propeller aircraft, in this case it can be driven by an internal combustion engine. But as you know, for aircraft it should be balanced, and usually internal combustion engine have a kind of vibration due to the reciprocating motion. So it is not preferred actually to have internal combustion engine to drive an aircraft. So usually we use gas turbine. And also in the marine application, safe ships and boats, you will find actually there is a big diesel engine. Usually it is a diesel engine to give more power to drive the ship. Also in grass cutting tools and wood cutting tools, there is a single cylinder spark ignition engine. Usually it is used actually in those applications. Okay. How we can classify shabab the internal combustion engine? It can be classified actually based on the application. It can be used in automotives like car, trucks, buses. All of these are actually automotive application. As I told you, it can be used in light aircraft, small aircraft. Internal combustion engine can be used. It can be used in marine application, outboard and inboard boats. Outboard shabab means the engine is outside the body of the boat. Inboard mean actually the engine is integrated within the body of the boat, and it can be used also for the ships. As I told you, there is a diesel engine can run the big ships actually to propel actually its propeller shaft to move inside the water. Also, it can be used in power generation. So if you look at actually at the companies or something, and even at homes, when we have electrical power shutdown or something, usually they use a diesel engine. This diesel engine is connected with an electric generator. The diesel engine is running with the diesel fuel. It generates shaft power. This shaft power is connected to an electric generator. Then it can generate electrical power for any reason actually for the electrical power shutdown. Have you seen this, Shabab, this model? We call it electric motor. Do you have one at your home? So this is a kind of application. Usually in some companies, they use actually this is a sub unit. In case of electrical power shutdown, they use actually this unit, a diesel engine, to drive an electric generator to generate electrical power. Also, it is used in agriculture application in tractor and pump for water pumping for the farm or something. Usually, they use a diesel engine, single cylinder diesel engine. Also, it can be internal combustion engine can be classified based on the engine design. We have a reciprocating engine, like the internal reciprocating piston. It can be single cylinder. The engine can be single cylinder in case of a small engine, or it can be multiple cylinder in case actually of bigger size engine. The engine also can be rotary engine, like the Wankel rotary engine. Inshallah, we'll be talking about this engine by the end of this chapter, inshallah, the idea about the Wankel rotary engine. Also, the internal combustion engine can be classified based on the arrangement of the cylinder. We said actually for big engine, we should have a number of cylinders. Those cylinders can be arranged in horizontal engine, horizontal shape, horizontal inline, or it can be actually two inline engine forming a vertical a V-type engine, or it can be vertical engine, inline engine, or it can be radial. All of them are connected on the radius, and we have the crankshaft at the center of this radius. Also, we have it can be classified based on the ignition method. We have a spark ignition engine, which is a gasoline engine. We have a spark plug to start the combustion, or it is compression ignition engine or the diesel engine, in which actually we inject the fuel directly within the cylinder and it self-ignites within the cylinder to generate power. Also, we can classify the engine based on the stroke. As I told you, any engine should be working on a cycle. If the cycle is completed in 4 stroke, we call it a 4-stroke engine. Or if the cycle is completed in 2 stroke of the piston, 2-stroke movement of the piston, we call it actually a 2-stroke engine. Inshallah, we'll look at this classification and the difference between 4-stroke and 2-stroke engine by the end of this chapter. Also, we can classify, Shabab, the internal combustion engine based on the fuel type. We call petrol engine or gasoline engine, or we can be diesel engine, or in some cases it can be gas engine. Some engine, Shabab, the internal combustion engine or the engine of your car can be modified to work on gaseous fuel like natural gas or hydrogen. It can be modified to this case. And in this case, we can call this as actually as a gas engine because the fuel is gaseous fuel in this case. Also, it can be operated, classified, engine can be classified based on the operating cycle. For the gasoline engine, usually the combustion is an instantaneous combustion that occurs actually at a constant volume. We call it constant volume combustion. And in this case, the system is working on what's called actually the Otto cycle. In case of ideal diesel engine, not the actual one, we consider the combustion take place actually at a constant pressure within the cylinder while the piston is moving, and we call this cycle actually as a diesel cycle. But in case of actual diesel engine, the real diesel engine, the combustion actually takes place, part of it takes place at constant volume, and the other part actually takes place at constant pressure while the piston is moving, and we call the cycle in this case as the dual cycle. Inshallah, we'll look at the difference between all of these cycles, inshallah, in a separate chapter, I think chapter 5. Also, Shabab, we can define, classify the engine, the internal combustion engine based on the cooling method. Some case of a small engine, like a motorcycle engine, usually the motorcycle engine is air-cooled, is a single cylinder engine. So actually the engine power is low and the heat actually generated is not that much. So in this case, the engine can be air-cooled. Usually they fix a fin or something, multiple fins around the engine to increase the surface area subjected to the air. Then in this case, actually the engine can be cooled actually by the air. But actually in case of bigger engine, like the engine in car, used in cars and in different automotive application, so in this case actually we use water in order actually to cool down the engine, because actually heating up, the heat up due to the combustion process here, Shabab, it will heat up the piston and it will heat up also actually the cylinder wall. So in this case we have to have a water jacket around this cylinder in order actually to cool down the temperature of the cylinder wall and keep the temperature of the engine within the safe limits. Okay. Let's look at actually the parts of the internal combustion engine. Any internal combustion engine should consist of the cylinder. Inside this cylinder we have the piston, which is actually moving actually in a reciprocating motion, and the top part of the cylinder, Shabab, we call it the cylinder head or cylinder cover. The cylinder head, it has actually the intake valve, and also it has the exhaust valve with the exhaust manifold. And in case of gasoline engine, it should be equipped also for each cylinder. We should have a spark plug to initiate the combustion process. Okay, this is actually the cylinder head, and we have in between the piston. So once we have the combustion have created inside the cylinder, then heat will be generated. So high pressure, high temperature will be generated within the cylinder. So it will push up this piston down, and the piston is connected to a connecting rod. This connecting rod is connected to the crankshaft. The idea or the function of this connecting rod is to convert the reciprocating motion of the piston into a rotating motion of the crankshaft in this case. So you can just look here. This is actually how this is, Shabab, how if you look at the motion of the piston, this is the motion of the piston. This is actually a reciprocating motion, and it is connected actually to the crankshaft. You can look here, actually this is the crankshaft motion, how it is moving. This is the piston moving up and down, and we have the connecting rod. While the connecting rod is moving, it is connected to the crank. Crank, Shabab, is the connection between the crank pin and the crankshaft, which has actually a counterbalancing weight here. So while the piston actually the piston is reciprocating, it moves actually the connecting rod, which moves actually the crank, so that actually we can generate a rotating shaft power of the crankshaft in this case. So if you look here, Shabab, there is also, if you look here actually, Shabab, at the connection between the piston and the crankshaft, there is a counterbalancing weight here. So what is the function of this counterbalancing weight, Shabab?
To reduce the
Sorry?
To reduce the vibration.
Yeah, exactly. The function of the counterbalancing weight here actually is to reduce the vibration. As I told you, the motion of the piston is reciprocating, so it results in vibration. So we have to generate a stable rotating shaft here. So we have to have counterbalancing weight in this case, connected to the connecting rod. If you look at the piston design itself, Shabab, this piston, you can see here there is actually a ring is here. There are piston rings. Those piston rings are actually a kind of from 3 to 5 piston ring. Those piston rings are either pressure ring. Those rings here, Shabab, usually we have 2 to 3 pressure rings. Those pressure rings are here just to seal the combustion gases above this piston from being actually leaked down to actually below the piston. So we have a kind of 2 to 3 pressure ring to seal the combustion chamber from actually the lower part of the engine. And also in addition to this, we have usually 1 to 2 oil ring. We have oil ring here. You can see this is the oil ring, inside which actually some oil, lubricating oil, is passed inside the cylinder to absorb actually the heat and reduce the temperature actually of the piston head. And it can transfer this heat through the oil to the walls of the combustion chamber. And then the walls of the combustion chamber can transfer the heat to the cooling water jacket around it. Usually, Shabab, those rings can be replaced typically after a kind of 100 kilometer of service. We have to replace actually the pressure ring, and also we have to replace also the oil ring. Okay. طيب if you look at the lower part of the engine يا شباب, the lower part of the engine which hosts actually the crankshaft, this part يا شباب is called as the crankcase. So it is a kind of a cover for the engine. But inside this crankcase يا شباب we have the oil pump, and all of the oil actually that dropping from the piston is just actually accumulated within this crankcase. And even يا شباب when the crank is rotating, if you look here, when the crank is rotating, the counterbalancing weight is just immersed here inside the oil, inside the crankcase, and it will splash this oil actually everywhere. And this oil will be coming to the inside part of the piston. The piston يا شباب is a hollow part. It is not actually a solid part. So the oil is splashed actually by the counterbalancing weight will be splashed inside actually the area inside this piston, just to cool down this piston, and also to lubricate the crankshaft. So while the crankshaft is rotating, it splashes the oil from accumulated within the at the bottom part of the crankcase, so that actually it splashes the oil everywhere, so it can actually lubricate the crankshaft. طيب, what is this part يا شباب? What is this wheel? What is the function of this wheel? It is a flywheel. What is its function?
To crank the engine.
Flywheel يا شباب is used to store the energy. So if you look at the 4-stroke engine, so usually we have a power stroke each 4-stroke. So if you look here, so we have only one power stroke while the piston is moving down. But what will happen during the exhaust stroke? So we don't have power. So while the power stroke, we burn the fuel here, generate heat, it will push the piston down. Now the power is coming from the piston to the crankshaft. But we need the piston to move up to exhaust the gases, and we need it to move down back to have actually the intake air. So that means actually each 4-stroke, we have only one power stroke in which the power is transferred from the piston to the crankshaft. But actually for the 3 strokes, the other 3 strokes, we need the power to transfer from the crankshaft to the piston, to move the piston, to exhaust the gases and have the intake air. And in those, the other 3 strokes يا شباب, the power is stored in the flywheel during the power stroke. Then this power is released actually with the inertia of the crankshaft to move the piston up and down during the other 3 strokes. So the function of the flywheel is actually to store the energy to be released from the crankshaft to move the piston while the other 3 strokes are going on, the other 3 strokes other than the power stroke. Is that clear يا شباب? Is it clear?
Yes.
So I don't know what is going on with the voice. Your voice is just cut it. So anyway, let's look يا شباب at this video. You can just look at it and see actually how the internal combustion engine is working. So do you hear the voice يا شباب? Do you hear it?
Yes.
So
Yes.
let's look at those components of the internal combustion engine and how. So this is the crankshaft. This is the crankshaft. We have the exhaust valves. We have those شباب are the camshaft. We have one camshaft for the intake valve and another camshaft actually for the exhaust valve. Those camshafts operated through this chain belt. This is actually this chain actually taking the power from the crankshaft to drive actually the 2 camshafts. So in which we have the camshaft, we have the cams are fixed, which actually open and close the intake actually and the exhaust valve. at any point, Shabab, you will find if we have an engine of 4 cylinder, you will have one engine is doing the power stroke. There is a combustion here, so it is going down. But actually, the other 3 piston one of them actually should be doing the exhaust stroke. One of them actually is during the intake stroke. The piston is moving down to suck air plus fuel. And the other one actually should be during the compression stroke. The piston is moving down. So usually one of the, if you look at any car, any small car or mid-range car, you will find the number of cylinder is usually actually 4 cylinder. Why it is 4, Shabab? Due to the firing order. One piston will be doing the power stroke, the other will be doing the other 3 stroke. Then actually this stroke, another piston. So this piston now is doing the power stroke, but the other 3 are doing actually the other 3 strokes. This is a kind of balancing for the crankshaft. So at each stroke, we should have one cylinder giving the power stroke. Okay? And also the firing order. So usually, if this cylinder has the fire, usually you will find each 2 pistons are moving together. So usually the second and third piston are moving together up and down. Usually 1 and 4, they are moving actually together. Both of them are moving actually. But at any time, Shabab, even the 2 pistons moving up or down, they are not doing the same stroke. You can look here. Those 2 pistons, this one actually is doing actually the compression stroke, and this one is doing the exhaust stroke, but they are moving together. So each 2 pistons are moving together just to balance actually the rotation of the crankshaft. Okay, is that clear, Shabab?
Yes, it's clear.
So we call this, Shabab, as the firing order. So usually the ones that have the power stroke, it fire usually the firing order of a 4 piston engine or 4 cylinder engine. 1, 2, 3, 4. Usually it is 2, 4, 2, 4, 3, 1. It is a kind of this sequence. So, but only at one time we should have one cylinder that have the power stroke, and the other 3 are actually doing the other 3 stroke. But if you look here, Shabab, at the camshaft, if you look at the gear here, Shabab, you will find this gear that receives the motion from this chain is almost double size of the gear that is connected to the crankshaft. Why, Shabab? The gear here that receives the motion to rotate the camshaft is almost double size the gear connected to the crankshaft. So why is that?
To reduce the speed.
Yeah, exactly, to reduce the speed, because this is actually a 4-stroke engine. 4-stroke, that means actually we need the intake valve, which is operated through this camshaft, to be opened one time for the 4-stroke. 4 strokes means what, Shabab? When this piston is moving down, so the crankshaft will be rotating half rotation. And when it is moving up, it will complete 1 cycle. So each 2 strokes, the crankshaft will be running 1 revolution. That means if the system is 4-stroke, so that means actually the crankshaft should have 2 revolutions for each cycle, each 4-stroke. But for each 4 strokes, the intake valve should open 1 time. That means the camshaft should be rotating at half speed of the crankshaft, so that actually it can open only the intake valve 1 time for each cycle, for each 4-stroke. So it will have only 1 revolution for each 4-stroke of the engine, but actually the crankshaft should have 2 revolutions in case of 4-stroke engine. But what about the 2-stroke engine, Shabab? 2-stroke engine? Exactly, they should have the same speed. And in this case, the size actually of the gear here should be the same size of the gear connected to the crankshaft in this case. Okay. By this, Shabab, we are done, inshallah, for today.